Okay, so this video is for my Algebra 2 students coming from CVCC. Your test is Thursday and Friday. This will give you a good review of sections 6.6 through 6.8. I will remind you that there's a quiz from 6.2, 6.4, and 6.5 quiz review video on my YouTube page as well. So you might want to look at that, especially at the factoring. Okay, but for right now we'll focus on the new stuff. Alright, so our first problem here, we're going to write the polynomial, and I'm going to give you zeros. So we're going to do two problems. Okay, so the first problem here, I'm going to give you x is 0 and x is 3 minus 2i. And you need to write the polynomial that has these zeros. Well, we need to know that if 3 minus 2i is a 0, then there is a conjugate pair that exists here. So we know that another 0 has to be 3 plus 2i. Again, remember that's called a conjugate pair. Alright. And now we create the factors. So here's my function f of x, my generic f of x. X equals 0. When you have x equals 0 as a 0, remember, it's just x. You could put x minus 0, but it's not going to affect the x. When you put these guys in factors, it's always opposite. X minus 3 plus 2i. Opposite, x minus 3 minus 2i. And now comes the fun part, multiplying. Let's start with these two guys. Always do the conjugate pairs together. So we're going to get 9 terms. X squared minus 3x minus 2xi minus 3x plus 9 plus 6i plus 2xi minus 6i minus 4i squared. The x squared comes down, it's the only one. Minus 3x is minus 6x. The minus 2xi and the plus 2xi cancel. Leave the 9 alone for a second. The 6i and the minus 6i cancel. And then this guy right here. Remember that I squared equals negative 1. So this guy, negative 4i squared, is going to turn into a positive 4. And now we do 9 and 4 and get 13. So that is the multiplication of our two conjugate pair factors. Let's bring that x on down. And let's distribute the x. X cubed minus 6x squared plus 13x. And here is your polynomial function with these given zeros. Okay, here's our next problem. Here's the 3 zeros I'm going to give you here. X equals negative 1, x equals 4/3, and x equals 2. And you need to find the polynomial function that goes with this. Okay, so no conjugate pairs here, so these are going to be our 3 zeros, so we're looking at a third degree polynomial. Always opposite, so we have x plus 1. Now here, remember how to change a fraction. It's opposite sign, and that denominator goes with the x. 3x minus 4, and then x minus 2. Okay, so be careful of those fraction ones, right? Opposite sign, denominator with the x. Now, I'm going to multiply these two outside guys because they're going to be very easy. All right, that 3 is a little bit complicated. So I'm going to do x plus 1 and x minus 2. So we'll get x squared minus 2x plus 1x minus 2. And we'll combine the middle terms, x squared minus 1x or minus x minus 2. And that is the multiplication of those two outside binomials. So now I'm going to bring the 3x minus 4 down in front. And again, it was just because there was a 3 with that x. I didn't want to worry about it first. Now I'm going to multiply these two guys. 6 terms is what I'll get. 3x cubed minus 3x squared minus 6x minus 4x squared plus 4x plus 8. And we will combine all like terms. The 3x cubed is alone. Minus 3x squared minus 4x squared is minus 7x squared. Minus 6x plus 4x is minus 2x. And then the plus 8 is the only constant. And there is our function. Okay, so be careful of those fraction zeros. Okay, so our next problems are going to be find all zeros problems. Okay, and remember, you can have, nice integer zeros, you can have fraction zeros, you can have imaginary zeros, you can have, quadratic formula, square root zeros, all kinds of things. All right. So if I give you a function, it's going to ask you to list all the possible zeros. So remember, let me change color. To do that, you have to list all the factors of the constant, what I called C, over all the factors of the leading coefficient. So we're doing plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1. All the factors of 4 over all the factors of 1. And since all the factors are over just 1, it's just these factors I have to check. Okay? So now you got to use your calculator. And you got to see which one works. See which one gives you f of whatever equals 0. See which one comes out to be 0. So use your calculator. Okay, I got one. It took me, about a minute and a half to try them all, because I had to go 5 deep. I had to try 5 numbers before I got one, because I do all the positives and then all the negatives. So I got -2 to work. So that means one of your zeros is x equals -2. So now we're going to use synthetic division to get this third degree down to a quadratic. So we have -2's out in front. My coefficients are 1, 4, 6, and 4. Bring down the 1, multiply by -2, add, multiply, and there we go. So my resulting polynomial is x squared plus 2x plus 2 equals 0. Okay, I'm going to use the discriminant to see if it's factorable or not. 2 squared minus 4 times a times c. And I get 4 minus 8, which is -4. 4 minus 8 is -4. Uh-oh. I know that my other zeros are going to be imaginary. So what do? I use the quadratic formula. Opposite of b, plus or minus the square root of my discriminant, all over 2a, 2 times 1. This is going to be -2 plus or minus. Now, I comes out and the square root of 4 is 2. 2i all over 2. And now, we do the pretzel. Divide those two, divide these two. -2 divided by 2 is -1. Plus or minus 2 divided by 2 is 1. And there's an I, so you don't need the 1. Just put an I. And there's your other 2 zeros. 1, 2, 3 zeros. Okay, I really like this problem. Okay, so again, find all the zeros. Here's your function. f of x equals x to the 4th minus 4x cubed plus 4x minus 1. So again, first thing, list all the possible zeros. Okay, so your constant here, -1, your leading coefficient, +1. Very small list. Okay, remember, just as an example, okay, over here, if you have like plus or minus 1, plus or minus 3, all over plus or minus 1, plus or minus 5, okay, then your zeros would be 1 and 3, and then 1/5 and 3/5. So this is like a side problem. Okay, does not have to do with this problem. No, does not. Okay, this is how you find all the other zeros. But this one only has 2 zeros to try, so our options are limited. Let's see. Okay, so fancy that. The first one worked. I got f of 1 equals 0, which means x equals 1 is one of my zeros. So I'm going to use synthetic division. Now, here's the kicker, and this is why I like this problem. If you look at your polynomial, there's something missing. Right there. Plus 0x squared. You better input that in your synthetic division. 1, -4, 0, 4, -1. Do not forget that. That holds for, long division and synthetic division. Make sure all your powers are there. All right. So we do the synthetic division, and here's what I get. X cubed minus 3x squared minus 3x plus 1. Sometimes you get lucky, and it's factored by grouping. This one is not factored by grouping, so we go back to our numbers, 1 and negative 1, plug them into this function. And lo and behold, negative 1 works. F of negative 1 comes out to be 0. So a second 0 here is negative 1. So we have 1 and negative 1. 2 of our 4 zeros. And now we do synthetic division again. So with the negative 1 and this polynomial, 1, negative 3, and 1. Bring down the 1, multiply, add, multiply, add, multiply. There we go. So what do I get? I got x squared minus 4x plus 1 equals 0. Okay, let's find the discriminant to see if it's factorable or not. Negative 4 squared minus 4 times a times c. Right, this is b squared. 16 minus 4, that's going to be 12. Not a perfect square, so we got to use the quadratic formula. Opposite of b, plus or minus the square root of your discriminant, all over 2a. And this has two problems, remember. There is the plus version and the minus version, and we'll figure those out here. Okay, so using my calculator for the plus, I get 3.732, and for the minus I get 0.268. Okay. Remember, if you're going to use your calculator and you want to do it all at once, parentheses around there, and then your calculator might have parentheses around the 12 inside the square roots. Okay, so finding all the zeros. Takes a little bit of time at the beginning when you're plugging them in, but once you go, synthetic division, and just keep moving forward. Okay, the last two problems I'll do are graphing problems. So we got to graph this function. It's in factored form for you so that you can find the zeros easy. You just need to know how to graph them. Okay, so if I look at this problem, all right. So first thing is the end behavior. My leading coefficient. No number here, so that's a positive 1. And the x's are both positive. So your leading coefficient is going to be positive, and your rule says positive leading coefficient means the right side is up. My degree. There's an x here, but it's squared. So that's 2 x's, and then there's a third x. So the degree is 3. An odd degree means opposite ways. So formally, as x approaches positive infinity, as x goes to the right, your f of x, your function, also goes to positive infinity. As x goes to negative infinity, that's the left, your f of x, will go down because it's opposite direction. Opposite direction. So there's the formal version. Then your zeros. Well, it's just opposite signs. So x equals positive 1 and x equals negative 2. And now we need to graph. So here's my piece of graph paper. I need to label, right, 1 and negative 2. 1 and negative 2. Okay, so bear with me as I do this. So we're going to go down, or we're going to start from down here, right, because the left side is down. And we're going to go up through negative 2. I'm going to really put a big dot there. We're going to go up through negative 2. And then we got to turn back down and come down to 1, but then 1, you know, see it's squared, so we don't go through 1, we bounce off, and that's how we finish up. So we're going to come down from down here, up through, turn back towards the 1, and then bounce off it. And there is our function. This right here is a maximum, and that right there is a minimum. And notice, third degree can have at most n minus 1 or 3 minus 1, which is 2 turning points, and it does. Okay, here's the last problem we'll talk about. Your function is x times x minus 3 cubed. Alright, so the first thing I will do is I will look at the end behavior. So my leading coefficient, positive out in front, positive x's, it's going to stay positive, which means the right side is up. My degree, I have an x here and I have an x here, but this x right here, third power. So there's really 3 x's. So there's 1 x out in front, 3 x's here, that's 4 total x's. That's an even degree, both sides are the same. So as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, your function still goes up to positive infinity. Okay. Now the zeros. Well, this right here out in front, if x is by itself, 0 is a 0. And then x minus 3, opposite sign, x equals 3. There's my zeros. So I need to grab my graph paper. On the graph, we're going to put 0 as one of my x-intercepts and 3. 1, 2, 3. Okay. So we're coming from up, and through 0, we just go straight through. But then at the 3, we're going to do that S-curve. Remember that cubed means S-curve. So we're going to come from the top, come down. I'm going to turn. And when I go through this point, I'm going to S-curve through. Whew. This is my first time doing graphs on here, so I think it's pretty good. Alright, so it goes through 0 because it only occurs once. S curves through 3 because it occurs 3 times. And up, there's my arrows. This point right here is a minimum. And there's your graph. Okay? So these 3 problems, these 3 types of problems, will be the main focal point of your tests. You need to go over factoring, long division, and synthetic division. Those 3 things from before. Factoring, long division, and synthetic division. And the other video has good review problems from there. Okay, so thanks for watching, and we'll see you on Thursday.